In today's video lecture, we will be talking about the resistors in parallel. So basically, what is a parallel connection? Two or more resistors are said to be in parallel if they have 2 points in common. So by 2 points in common, we means that, let's consider if we have two resistors R1 and R2 and they are connected to the same points in this circuit. So by the same points, we means that R1 and R2 are connected to point A and R1 and R2 is also connected to point B. So these two resistors are sharing the same 2 points. So these two resistors are in parallel. We can also connect these two resistors like this. In this case, these two resistors are also sharing 2 common points. R1 and R2 is connected to point A and R1 and R2 is also connected to point B. So these two resistors are said to be in parallel. Now to understand this parallel connection in a more brief way, let's take an example in which we have a DC voltage source which is connected in parallel with two resistors R1 and R2, and let's say V1 is the voltage drop across the first resistor and V2 is the voltage drop across the second resistor. Now for parallel connection, the voltage drop across the first and the second resistor is equals to the input voltage, or simply we can say that V1 is equals to V2. The voltage drop across the first resistor is equals to the voltage drop across the second resistor, which is equals to the input voltage to this parallel circuit. It means that the potential at this point is the same as the potential of this DC voltage source. But in parallel connection, the current is divided because there are more than one path available for the current to flow. Now, according to the law of conservation of charges, we know that the charges cannot be created nor destroyed. So it means that the current through this source, which is Is, will be equals to the sum of all the current through these resistors. So the current through this source is Is, which is equals to the sum of all the current through these resistors. Let's say the current through R1 is I1 plus the current through R2 is I2. Now according to Ohm's law, E would be equals to Is into RT, where this RT is the equivalent resistance of this parallel circuit, and this Is is the input current through this source, and E is the input voltage. Now to find out Is from this equation, Is would be equals to E divided by RT. Now as we described earlier that the voltage is the same at this point. So according to Ohm's law, I1 would be equals to E divided by R1. And similarly, I2 would be equals to E divided by R2, because the voltage is the same across each resistor as the input voltage. Now by putting these three equations here in this equation, so we get, now instead of Is, we can write down E divided by RT is equals to I1 is equals to E divided by R1 plus I2 is equals to E divided by R2. E divided by RT. Now E is common in this side, so by taking E common, so we get 1 divided by R1 plus 1 divided by R2. So E will cancel E. So as a result, we get 1 over RT is equals to 1 divided by R1 plus 1 divided by R2. So this is basically the equivalent resistance of a parallel combination of resistors. Now if there are n number of resistors connected in parallel, then 1 over RT would be equals to 1 over R1 plus 1 over R2 plus 1 over R3 up to 1 over Rn. So if there are n number of resistors connected in parallel, so the resulting are the equivalent resistance of this parallel connection is equals to 1 over R1 plus 1 over R2 plus 1 over R3 up to 1 over Rn. Now by simplifying this equation, we get 1 over RT is equals to, the LCM of this equation is R1 R2. So we get R1 plus R2. So the resulting equivalent resistance of this parallel connection will be equals to R1 R2 divided by R1 plus R2. And from this relation we derived that the total resistance of this, or the equivalent resistance of this parallel connection, will always be less than the less resistance in parallel. Now to understand this in a more brief way, let's take another example in which we have a DC voltage source which is connected in parallel with three resistors R1, R2 and R3. And R1 is having a resistance of 10 ohms, R2 is having a resistance of 220 ohms, and R3 is having a resistance of 1.2 kilo ohms. And here we have a 24 volt of potential difference across this DC voltage source. And let's say Is is the current through this DC voltage source, and I1 is the current through R1, I2 is the current through R2, and I3 is the current through R3. And if we are asked to find out the total current from this source and the current through R1, R2 and R3. So as we described earlier that the voltage is the same through each point in this circuit, but the current is divided. So first of all we need to find out the equivalent resistance of this parallel circuit. So the equivalent resistance is 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 O divided by R3. So as 1 over RT is equals to R1 is 10 ohms plus 1 over R2. R2 is 220 ohms plus 1 divided by R3, which is 1.2 kilo ohms. Now after calculating this, we get 1 divided by RT is equals to 0.1054 per ohms. So the RT from this equation would be equals to RT is equals to 1 divided by 0.1054 ohms. So the resulting equivalent resistance of this parallel circuit is 9.49 ohms, which is less than the least resistance in this parallel connection, which is 10 ohm. So from this we prove that the equivalent resistance, or the total resistance of this parallel connection, is less than the least resistor connected in parallel. Now to find out the total current from this source, by using Ohm's law we know that E is equals to Is into RT. So to find out Is from this equation, Is would be equals to E divided by RT. So this E is already we have, which is 24 volts, divided by RT, which is 9.49 ohms. So the resulting current through this source is equals to 2.53 ampere. So here we have total of 2.53 ampere of current from this source towards this parallel connections. Now to find out the current I1, so by using Ohm's law, I1 would be equals to E divided by R1, because the voltage or the potential is the same as the potential of this DC voltage source. So the potential of this DC voltage source is 24 volts divided by R1 is 10 ohms. So the resulting current through this R1 resistor is 2.4 ampere. So I1 is equals to 2.4 ampere. Now by using Ohm's law again to find out the current through this R2 resistor, which is, let's say I2, is equals to E divided by R2. A is already we have, which is 24 volts divided by R2 is 220 ohms. So the resulting current through this branch is 0.1091 ampere. Now the current through this third resistor is, let's say I3, is equals to E divided by R3. E is already we have, which is 24 volts divided by R3 is 1.2K is equals to. So the resulting current through this branch is equals to 0.02 ampere. So from this we can analyze easily that the least is the resistance, the more will be the current through that resistor in the parallel connection. So from 10 ohm resistor, 2.4 ampere of current is flowing through this resistor, and from 220 ohm, 0.1091 ampere of current is from this resistor, and as that of from the third resistor, the least current is flowing through this third resistor, because The resistance value of this third resistor is much higher than as compared to the first resistor and the second resistor. If you have any doubt, ask in the comment section. See you in the next one.